Hello, today we're covering electromagnetic waves. There's an article, I'll link in the description. So very fast, what we have is, so you have an electromagnetic wave. There's an electric and a magnetic portion because it's an electromagnetic force that it's associated with. We'll go over some terminology to deal with the waves and then some quick equations. So you have something called crest is like the top of the wave, basically. So if you have the wave like this would be the crest. The trough, bottom of wave. And so that's right here. And the wave could just go on forever. And each of, this is a crest, this is a crest, this is a trough. Okay, so now we'll go over amplitude. This article defines it as distance from tip of crest to central axis. So it would be, if this is the center, it would be this distance right here. We have wavelength, distance between subsequent troughs or crests. Kind of self-explanatory a little bit here. Don't worry, we'll get to some physics soon. Well, semi-physics related equations at least. And then we have frequency. And it's basically wavelengths per unit of time, I guess. Wavelengths per second. Per unit of time, I guess. We'll be using seconds, I think. But I don't think we're using anything. We're just going to go over some equations really quick, but usually you would use seconds. So, okay. So frequency is, okay, so the speed of light would have to equal the wavelength times the frequency, and we're using a Greek letter nu over here. Yeah, that's frequency. Kind of bizarre, but basically because I mean, yeah, this equation is true. Speed of light is equal to wavelength times frequency for electromagnetic waves, because they're always traveling at the speed of light, or at least very close to it. And so this would hold just from some mathematical definitions of the wave, I'm pretty sure. So now, so we have something called the period. It's 1 divided by the frequency. It's like the amount of time per wavelength, since frequency is wavelengths per amount of time, so you invert that. And then you have an equation from Max Planck, I think. It says the energy in a photon, I'm pretty sure, would be equal to this constant right here times the frequency of the light, and that's pretty useful. And that's pretty much it. So yeah, energy in a photon is equal to this constant times the frequency. I'm pretty sure. Okay. I hope you enjoyed. Have a good day.